We are watching sample loading and automated analysis of polymer samples for intrinsic viscosity on the Model 575 Intrinsic Viscometer from Haiku Instruments. Lined up right now are 5 samples. These are HPMC, these are running in water, dissolved at 40 degrees Celsius for 30 minutes, and then transferred to the oven for subsequent analysis, again at 40 degrees Celsius. The loading and analysis takes place in an automated fashion. No user intervention is required. In fact, these samples were weighed out earlier today using the connected analytical laboratory balance you can see here. After the sample has been loaded, there's a short equilibration time, after which the sample is injected, and we go from a baseline measurement of solvent viscosity versus solvent viscosity. So we're getting an instrument constant. Then the sample is injected, and we go up to a plateau, and that's the relative measurement. With the relative viscosity and the sample concentration, we can use the right physical chemistry equations to get the intrinsic viscosity. Right now we're at baseline, waiting for 200 data points at 16 hertz. We have an injection. Sample goes up towards plateau. Within 1 minute, we get the data for one injection. Then we have loading, and then we have, again, a subsequent injection. This is what we call classic mode. In classic mode, what we're doing is emulating older automated capillary systems that were operating on what we call synchronous or serial connections. Only one action can be taken out at any given time. Modern instrumentation uses asynchronous programming, allowing us to control multiple components all the time. This is what you've come to expect over the course of your career. And this is what we've done, is take those older methods and update them. You can see what we're doing is drawing some sample from the vial, drawing an air segment, and then again sipping back into the vial. This allows us to prevent carryover. So it doesn't matter if we run high intrinsic viscosity samples first and then go to low or low to high. We wash the system, we wash the injection system with the sample before the injection, and then the capillaries are washed automatically by the system during this loading period. Some samples can be run in this fashion. Others that have a higher affinity for the capillary material require us to run in this classic mode. What Haiku patented in 2023 was our rapid fire mode. In this way, we are looking for the baseline, and instead of waiting a fixed amount of time, we're waiting until we have a certain amount of data that meets minimum quality standards, a certain amount of confidence. And then if the subsequent sample has already been loaded into the on-deck sample loop, and those criteria are met, we automatically inject. This cuts down on the vast majority of the time that's needed, which is loading. So we go from historical systems that run maybe 4, maybe 5 at most samples per hour, to the Model 575 from Haiku Instruments, which is running 12 samples per hour in duplicate. That's 24 injections per hour, all carried out without any user intervention. Again, we're running in water, and all of our waste is going to this other container. Sample preparation volumes are around 20 milliliters, and the analysis requires a further 2 or 3 milliliters of solvent for flushing and cleaning the system. Whether we run our samples at high or at low concentration, the intrinsic viscosity values obtained are identical. This is simply important that we run below the critical concentration at which you break out of the dilute solution criteria. That dilute solution criteria is that the polymer is not interacting. You're not getting multiple polymer interactions. The rheology that's going on in solution is being dictated by the polymer solvent interactions and not polymer interactions.